hear me?
Yes.
Okay, so welcome to lesson 6, and we will just start with homework review. So does anyone want to share their solution from the homework? If no one does, then I'll just do it. So we have to simplify this expression. So how do we do it? We first simplify the part inside right here. So we would just have 2 times n squared to the negative 2 power to the squared will just equal 2 times n to the 2 times negative 2. We have this from the rule right here. Okay, so and then squared. So this would equal 2n to the negative 4 squared, which would then just give us 2 squared equals 4. So it's just 4 times n to the negative 8. Questions? No questions, and I'll move on to the next one. So for this one, we would just have, if we're given that 5 to the n equals 2, and we're asked to find the value of 25 to 2n plus 1. So how do we do this? We just do this. So 5 to the n equals 2. So if we square both sides, it gives us 5 to the 2n equals 2 squared, which is 4. So we have 25 to the n is equal to 4. Because it's just like 5 to the square to the n, which is 25 to the n. And if we square both sides of this expression again, it will give us 25 to 2n equals 16. But we're asked to find 25 to the 2n plus 1. So we just multiply both sides by 25, which gives us 25 to the 2n plus 1 would equal 16 times 25, which is 400. Questions? No, then I'll move on. So last week we did these. So last week we did factoring quadratics. So this week I'll go over solving quadratics. So you can solve quadratics by factoring them. So when you solve a quadratic, which is like this one, you're finding the value of x such that the expression equals 0. the solutions are called the roots or zeros. And if AB equals 0, then A or B must be 0. By the same reasoning, if AX plus B times CX plus D equals 0, we have either AX plus B equals 0 or CX plus D equals 0. So I'll give you guys a few minutes to solve this problem. Okay, so I'll go over this problem now. And we're asked to solve the expression 6x squared equals 7x plus 3. So we can solve this by noting that 6x squared equals 7x plus 3 can also be written as 6x squared minus 7x minus 3 equals 0. Okay, and so this expression is also in the form like this. So if we can just factor this expression right here, we can find the roots. So to factor it, we can just do this. So we want to split up the 6 into two multiples. So it can either be x and 6x or 2x and 3x. For each of them, we can try to find two more on this side such that the product of this and this and the product of this and this added together added together should equal negative 7x. So after a bit of trial and error, we can just do negative 3 and 1. This would give us an answer. So it would be 2x minus 3, which is this row, times 3x plus 1, which is this row, equals 0. So we can multiply them out and we can find that it is this expression right here. So the answer would just be 2x minus 3 equals 0, or 3x plus 1 equals 0. And solving these two will give us x equals 3 over 2 and x equals negative 1 over 3. And these are our answers. Questions? No questions, and I'll move on. So we can also solve quadratics by completing the square. So note that this ax plus b squared is equal to a squared x squared plus 2abx plus b squared. We can complete the square for an arbitrary quadratic by adding a constant to make it into that form. So for example, if you're asked to solve the expression x squared plus 2x plus 2 equals 0. So for this, we know that x squared plus 2x plus 1 equals 0 is a perfect square, namely x plus 1 squared. So if we add, so we can just do this. This would just become x squared plus 2x plus 1 equals 0. So we would have x plus 1 squared equals negative 1. But we have a problem here because a square of any integer or any real number is always positive, but negative 1 is negative. So this equation, the equation right here, would have no solution. So the specific formula is ax squared plus bx plus c equals 0 implies that a times x plus d squared plus e equals 0, where d is equal to b over 2 and e is equal to c minus b squared over 4a. However, it's useful to figure out how to complete the square manually. So I'll give you guys a few minutes to solve this problem. Okay, I'll go over this problem now. So we're asked to solve x squared plus 6x plus 7 equals 0. So we have x squared plus 6x plus 7 equals 0. And now we want to find a constant such that if we add the constant to x squared plus 6x, x squared plus 6x, x plus that constant will become a perfect square. So using the formula right here, we know that a would equal 1. So we have 2b equals 6, so b equals 3, so b squared equals 9, so the constant will be 9. So if we add the constant to this expression and we minus the constant again after, it will give us x squared plus 6x plus 9 minus 9 plus 7 equals 0. So x plus 3 squared would equal 2. After that, we would have that x plus 3 equals plus minus of root 2. And be careful here, we use plus minus because root 2 squared equals 2, but negative root 2 squared also equals 2. So we need a plus minus sign here. And then if we subtract 3 from both sides, we will get x equals negative 3 plus minus root 2, which is our answer. Questions? No questions, and I'll move on. So we will move on to the quadratic formula. The quadratic formula is an extremely important formula that you need to memorize. So we can use the quadratic on literally every quadratic to solve it, while factoring will only work on those quadratics that can be factored. So it directly tells you the solution to the quadratic even if it's not factorable. It's derived using the technique of completing squares and some algebra, though it's not important to memorize why it's true. And it's really hard to prove it. So if ax squared plus bx plus c equals 0, then we have this. Actually, it's not really hard to prove it. So I can try to prove it right here. So we have the ax squared plus bx plus c equals 0. So if we try to complete the square, it will just be ax squared plus bx plus c equals 0. And we try to add a constant to this expression to make it a perfect square. So for this, suppose that dx plus e squared equals d squared x squared plus 2de plus e squared. So right here, the d would equal root a. So the 2de would equal b. And then after that, we would have that 2e equals b over root a. And then e would equal b over 2 root a. And then we will derive that e squared equals b squared over 4a. Okay, so ax squared plus bx plus c, wait, no, sorry. Bx plus b squared over 4a minus b squared over 4a plus c equals 0. So we would have that a, actually root a times x plus b over root a, b over 2 root a squared equals b squared over 4a plus c, minus c, minus c. So we would have that root a x plus b over 2 root a equals b squared minus 4ac c over 4a, and that's a square root, the plus minus square root. So this will give us that 2 root a, so 2a plus b, 2ax plus b over 2 root a equals plus minus of the square root of b squared minus 4ac over 2 root a. And then after that, we can cancel these two. Let me add a page. To give us 2ax plus b equals plus minus root b 平方 b squared minus 4ac. So 2ax equals negative b plus minus root b squared minus 4ac. So therefore we have x equals negative b plus minus 2, the square root of b squared minus 4ac over 2a. So we have proven our quadratic formula. And if the part under the square root in our quadratic formula is negative, then we will have no real solutions. But we may have imaginary solutions, which I'll not go over in this lesson. And if it is 0, it will only have one solution, namely it will just be negative b over 2a, because it's just negative b plus minus 0. And obviously if it's plus and if it's minus, it would both equal negative b over 2a. So I'll give you guys a few minutes to solve this problem right here. Okay, so I'll go over this problem now. So we're just asked to find 2x squared minus 4x minus 7 equals 0. We're asked to find the zeros of this. So it's just a straightforward application of the quadratic formula, which states that negative b plus minus the square root of b squared minus 4ac over 2a. So this gives us, because b equals negative 4, so it's 4 plus minus 4 squared, negative 4 squared, which is 16, and then minus 4 times 2 times 7, which is just 8 times 7, which is 56, but there's a negative in front of the 7, so it's negative 56 over 4, which then gives us 4 plus minus root of 72 over 4, which is equal to 4 plus minus 6 root 2 over 4, which is just 2 plus minus 3 root 2 over 2, or we can write it as 1 plus minus 3 root 2 over 2. Questions? If no questions, then I'll move on. So next, we have word problems. So usually word problems lead to quadratics, especially if we know the product of two numbers and another linear relationship between them. You can also solve them in any way, but you must keep in mind the conditions of the problem. So I'll give you guys a few minutes to solve this problem right here. Okay, so I'll go over this problem now. So we have the width of the rectangle is 1 centimeter less than 10 times of its length. Find the perimeter of the rectangle if the area is 60. So suppose that the length is L. So we have the width equals 10 times L minus 1. So the area is just the width times the length, which is just 10L minus 1 times L, which is 60. So we just have that 10L minus L minus 60 equals 0. So therefore, using the quadratic formula, we have 1 plus minus root of 1 plus 2,400 over 20 equals 1 plus minus 49 over 20. But we have a problem here because this is L. Because the length must be greater than 0, so it can't be 1 minus 49. So it must be 1 plus 49. So we can just do this. So we have that the length equals 5 over 2. And then, since the length is 5 over 2, we have the width is equal to 10 times 5 over 2 minus 1, which is 24. So we have that the perimeter is 2 times the width plus the length, which is just 2 times the width plus 2 times the length, which is just 5 plus 48, which is 53. Questions? Nobody has any questions, then I'll move on. So we have the sum and product of the roots. So this is also called the Vieta's formula. We note that every quadratic can be written as 2 times x minus r times x minus s, where r and s are the roots. And if you expand this, you find that b is equal to negative a plus r times r plus s, and c is equal to ars. So the sum of the roots, which is r plus s, equals negative b over a, and the product, which is rs, equals c over a. And I have another way of deriving the Vieta's formula, which is using via the quadratic formula. So for the quadratic formula, we have that negative b x equals negative b plus minus root b squared minus 4ac over 2a. So suppose the roots are, say, x1 and x2. So x1 equals negative b plus square root of b squared minus 4ac over 2a. And x2 equals negative b minus root of b squared minus 4ac over 2a. And we can do both of the operations now. So x1 plus x2 will just equal negative 2b plus square root of b squared minus 4ac minus square root of b squared minus 4ac. And these two just cancel over 2a. So just gives us negative b over a. And x1 times x2 would equal negative b plus square root of b squared minus 4ac times negative b minus square root of b squared minus 4ac over 4a squared. And then we can just use difference of squares on the numerator, and this will just give us b squared minus b squared plus 4ac over 4a squared. So these two will cancel, this will cancel, and this will give us a 1. So which is just c over a. So we have our Vieta's formula. Okay, so I'll give you guys a few minutes to solve this. Okay, so I'll go over this problem now. Suppose that the roots of 3x squared minus 7x minus 18 are m and m. We're asked to find 1 over m plus 1 over n. So putting them on a common denominator, we just have that it's m plus n m plus n over mn, and Note that m plus n is the sum of the roots and mn is the product of the roots. So we can just use Vieta's formula, which gives us that the sum is just negative of negative 7 over 3, which is a 7 over 3, over negative 18 over 3. Canceling these two, we have that it equals negative 7 over 18. Questions?
Can you move up a little?
To where?
That's fine.
Good, Alan?
Yes.
Okay.
I thought you meant something else.
No. Okay, so I'll give you guys a few minutes to try and solve these in-class problems. And after that, I'll go over to this and then have you guys try and do these two problems and class will be done. Okay, so I'll go over these problems now. So, first problem, the length of a rectangle of area 10 centimeters squared is 1 centimeter greater than 3 times its width. What is its perimeter? So, the length is equal to the width plus 1. So 3 times the width plus 1 times the width equals 10. So 3w squared plus w minus 10 equals 0. And we can factor it as following. So 3w, w, negative 5, 2. So 3w minus 5 times w plus 2 equals 0. So either it's w equals 5 over 3 or w equals negative 2. But the width must be positive, so we can eliminate the possibility of the width equals negative 2. So after that, we can find that the length is 6. So the perimeter would just be 5 over 3 plus 18 over 3 times 2, which is 2 times 23 over 3, which is 46 over 3. And then after this, for the second problem, we're asked to solve 2x squared plus 4x minus 7 equals 0. So we can just use the quadratic formula, negative 4 plus minus square root of 16 plus 56 over 4, which is negative 2 plus minus 3 root 2 over 2. And note that this one, the second problem, is the same as this problem right here, except that this is plus instead of minus. So we only need to add a minus to these, and that will give us our solution to that previous problem. So yeah, any questions on this one? No, then I'll move on. So these are the last two questions. So we have nested square roots and continued fractions. So suppose it's root of a plus root of a. Whoops. Sorry. Plus root of a plus all the way to infinity. So suppose that this is s. What can you say about this? This is also s because infinity technically equals infinity minus 1. So s would just equal square root of a plus s, and then you can just square both sides and solve the quadratic. And it's the same for continued fractions. So I'll give you guys a minute to solve this problem.
Wait, what does S equal again?
S is just a sum.
No, but like, what's behind it?
What do you mean? What's behind it?
Like, you wrote S equals square root something. Or like,
So like, you can just square both sides. S squared equals A plus S. And this is just like the equation x squared equals A plus X, where A is a constant. So yeah. Okay, so I'll go over these two problems now. So for the first one, suppose S equals this thing. So we find that this also equals S. So it's just root 6 plus S. So S squared equals 6 plus S. So S squared minus X minus 6 equals 0. And we can just factor it out. Gives us S plus 2 times S minus 3. So we have the roots are S equals -2 and S equals 3. But obviously, a square root of a number must equal a positive integer. Must equal a positive number, not an integer, a positive number. So the S must be 3. And for the second one, we suppose that T equals this. So T plus 2 equals 2 plus 1 over 2 plus 1 over 2 plus 1 over 2 plus blah, 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 up to infinity. And then we find that this also equals T plus 2. So T plus 2 equals 2 plus 1 over T plus 2. So T plus 2 squared equals 2 times T plus 2 plus 1, which gives us S squared plus 2S minus 1 equals 0. So not S squared. T squared equals 0. So T, using the quadratic formula, will just equal -1 plus minus root 2. But since this must be positive, we can't have the negative. So it would just be -1 plus root 2. Questions?
could you move up, please?
Here?
Yeah.
You good now?
Yes.
Okay. So I'll give you guys a few minutes to solve these two problems. Okay, I'll go over these two problems now. So for the first one, suppose that this is S, then we have that this is also S. So S would equal 1 plus 3 over 2 plus 3 over S. And then S times 2 plus 3 over S equals 2 plus 3 over S plus 3. So 2S plus 3 equals 2 plus 3 over S plus 3. These two cancel. And we have 2S squared equals 2S plus 3. So 2S squared minus 2S minus 3 equals 0. And then after, we just solve using the quadratic formula, which gives 1 plus root 7 over 2. We don't use plus minus here because we know that the fraction cannot be negative. So it's just 1 plus root 7 over 2. And for the second one, we're asked to find the cube of this number. Suppose t equals this, then this is also t. So t equals 2 times the square root of 3 times the square root of t. So t over 2 equals square root of 3 root t. So t squared over 4 equals 3 root t. So t squared over 12 equals square root of t. And then we have that t to the fourth over 144 equals t. And these two cancel to give us t to the third. And if we multiply 144 to both sides, we have that 2t to the third equals 144, which is what we're asked to find, since we're asked to find the cube of the number. Questions? If no, then that's it for today's class. And also, don't forget to do the homework for the class. Okay. So that's it. You guys may leave now.
Thank you. Bye.